Welcome to qnawire.
So in this problem, we have a rectangular loop of wire here on the left, and then we have a long, just single wire on the right. So on the left, we have current I1, on the right, we have current I2, and then we have all of the relevant distances. And so we want to find, in part A, what the net force on this rectangular loop of wire is. So to start, let's label all these sides of this loop. So we'll say side 1, 2, 3, and 4. So right away, because sides 1 and 2 are carrying the same magnitude of current, these are just going to produce forces that cancel out. So from the right-hand rule, side 1 is going to be making a force in the upward direction. Side 3 will be making a force in the downward direction. So they'll cancel each other out because they have the same current through each other and they're the same distance away from the wire. So we don't have to worry about those. So we can just say then the net force is going to be the force from wire 2 plus the force from wire 4. And again, with the right-hand rule, we could see wire 2 will make a force going out like there, and wire 4 will make one out that way. So I just want to deal with only the magnitudes of these two forces, so I'm just going to kind of build into the equation that F2 is negative, and then F4 is positive. So now we just need to know what form these forces take and how to solve for those. So we know that for a wire, the force on it due to a magnetic field is just going to be that magnetic field times the current in the wire times the length of the wire. So our magnetic field is coming just from this big long wire here. And so we know that's always going to be mu naught times its current over 2 pi r. So then adding in these other terms, we'll then have I1, and then we'll have L. So this is just our general form for what the forces from wire 2 and 4 are going to take. So now we just plug in the specifics. So it looks like we could factor out always a mu naught I2, I1, L over 2 pi. So the only things that are going to be changing here are the r. So we said F2 is negative, so we're going to have a minus 1 over, and our distance for wire 2, we have 5 centimeters plus 7 centimeters, so 0.12 meters. Oops, that's a point. And then we have plus for F4, and F4 is only 5 centimeters away, so 0.05. So we plug in our lengths for these, so 0.26 meters, and then we have I2 as 100 amps and I1 as 2 amps. So plugging all those in, and we get a positive 1.2 times 10 to the minus 5th, or 5 newtons. And so that's in the x hat direction, so being pulled towards the big wire. Then question or part B asks us to find the net torque on the wire. But we know the net force is just in the rightward direction, so all there is just a force going like that. And more so, all these forces are in the same plane as each other. So there's really no way to make a rotation acting here, at least because all these forces are acting like we can treat them as a big force, but really it's like a consistent, smooth bunch of little forces here. So there's no way there's going to be a net torque here. There's no way these can be causing a rotation, at least if all these forces are in the same plane like this. So there's just no torque.